This is a Sony EVS3000 Hi8 home deck with PCM digital audio. This was the first Hi8 with PCM home deck that Sony offered, and this one is not in good shape. Now with this deck, Sony tried to launch into the home video market as a recorder to record your TV shows on, to kind of replace their Betamax, basically. You play your camcorder tapes on it, you could record and play it, had a timer on it. Full function with digital audio that you could dub.
I don't know what's wrong with this unit. It was shipped in, so before even powering it up, I figured I better take this one apart and just take a look and see what it's doing, or what it's not doing, or even if it will power up. Now I did notice that the screws that hold the cover on were loose, so someone's been in here at some point. Someone's done work on this, but what was done on it, that I don't know. Since I don't know the history, it was shipped in, so we're going to plug it in and see whether it does anything. Whether it will turn on, or you hear that noise? We got power supply problem on this. It's squealing like crazy. So we got to pull the power supply and go through that first. Don't know if you heard it. I can certainly smell it. It smells like caps are going bad. I can smell them already. What we need is smell-o-vision, but it smells like fish. So we're gonna have leaking caps on this thing. Absolutely, positively guaranteed that that's going to be part of the problem on this machine. These are pretty old, these units. This was the first, I think this was the first generation, if I'm not mistaken, Hi8 deck that was sold that had the PCM audio, and it also has a time-based corrector. So that gives you an idea. This would be, I guess, late 80s or early 90s. So power supply just lifts out on this one, the module, if I'm not mistaken. It should lift right out. I may have to loosen the screws on the bottom and lift the bottom off. It's been so long since I've opened one of these up, I've forgotten how to get into them. All these screws are loose. Yeah, you can see, look, it's been leaking. And unplug the plugs on the bottom here to lift the power supply out. Yeah, there's corrosion right down here on the pins. Okay, now I can lift out the power supply module. We'll set the unit aside for now. We'll deal with this mess. And a mess it's going to be. Guaranteed. It's going to be an absolute disaster in here. Oh my God. Is that not a sight? And I don't mean that in a good way. That is just horrible. We have caps that have been leaking. We've got foil traces that are going to be damaged. Just a nightmare. You'll hear the electric furnace running in the background because it's a little bit cool today. We had a bit of a cold snap here over the last couple of days. In fact, it actually snowed. Didn't snow much. Less than an inch. About 2 centimeters maybe. But it cooled down. It cooled down to the freezing point last night. It's above freezing now, but a little bit chilly here in the shop. So we'll remove these screws and lift the board out and start the board surgery. I can lift this back piece off on this unit. If I'm not mistaken, pop these catches out and lift the whole back off, then I can just lift the entire cage away. Just like that. Leave this rusty mess over there. Okay, so this has got our famous Elna craps in it. And we're going to have to change out a bunch of them and clean up the board. You can see right here, it's leaked over my hands too. Yeah, this is just, it's all over the regulator here. This trace here has got corrosion on it. It's quite the mess. It's going to be all these ones here that are leaking. All these brown Elna caps are bad. I'm going to have to replace these all, but we're going to have to change these all for sure and clean up this board. No other way this thing's going to work, and it's going to be more than just this as well. This is just the start, and there's going to be a lot more than just these caps. Like, not just this, I'm talking on the board, on the unit itself. There's going to be more capacitors bad, guaranteed, in the unit, and more than likely inside the time-based corrector is going to require a bunch of them too, because they did go bad on these units. This is the problem with all this old vintage stuff that people want to hang on to, is that you know, sometimes the cost of maintaining it is relatively high. But first things first, let's clean off this board. I'll wash it off with some isopropanol and a toothbrush, and we'll get the board clean first, and we can start. One thing we should note on a power supply like this is this had a crowbar system built in. If you look at that, there's an SCR right here, right? Little SCR, and there's a Zener diode here. So what happened on these power supplies, that's probably why it was squealing when I plugged it in, is this is tripped. If the voltage goes too high, it triggers this SCR, which basically puts a short across the power supply. If you look at the anode and the cathode, you'll see that they actually provide a dead short right across. See here? Here's the gate, which is going through this Zener diode and a resistor. There's the Zener right there, right? It goes to the gate, and if the SCR trips, it'll short the anode and cathode together, which is right across this filter C12. So this will kill this line if the voltage goes too high, right? So that might have been why it was squealing, is because it was in protection mode. But and of course there's a fuse here. There's a couple of fuses. Most of these caps here, I don't have enough of them in stock. I'm gonna have to go get some. They're 1,000 microfarad at 16 volt, which I'll probably up it to 25 because I just don't normally stock 16s. And 470s and so forth. So I got to get some stock of some small caps. All these Elna ones are going to be bad for sure, no question, because Elna had just a nasty habit of just leaking and spewing their corrosive crap from the unit itself onto the board. As you can see, gravity is taking it down, and it's all along the bottom edge here. And of course, then it's soaked all the way along into the board, and it's probably done some damage. I don't know whether the traces are open. We'll have to measure it, but I'll be cleaning all this up. We'll get this all clean and then go from there. So this is what ashtrays are good for in non-smoking homes. Putting your cleaner in so you don't contaminate the rest of the jar when you're cleaning this crap up, because it'll, of course, migrate onto the toothbrush, and you don't want to dip that back into your full uncontaminated isopropanol, because we use it to clean other things. It needs to remain pure. So I just put a little bit into a non-food glass dish. In this case, it's an ashtray. But sometimes I use it like an old jar or something. We're going to clean this crap up off the board. And I'll clean the other side as well, best I can. But I'm more concerned about what's happened to the traces here. These traces I'll likely remove the solder mask and go over them with solder, just to make sure that there's no breaks, because this is the feedback circuit. So if we lost the feedback here on the optocoupler, that's this one right here, that would cause the voltage to go too high and trigger that SCR, which would of course shut the power supply down before something went boom in the rest of the circuit, which is something that Panasonic should have learned back in the early 80s. Well, actually they did. They learned it the hard way back in the early 80s because there was a bunch of VCRs like the PV, I think it was the PV1361 or 1365, somewhere in there, one of those ones, that they came in and they were all blown up, like blown to smithereens because a power supply, a 12-volt rail went up to like 50 volts, started popping chips, and the 5-volt rail went up to like 40 or 50 as well. They just did a lot of damage. That was an oops on Panasonic's fault there. They had some pretty bad power supplies in some of their machines there in the 80s when they went to switch mode supplies. Of course, they solved that by putting a Zener diode to short it out. But the problem with having a Zener diode shorting it out was that the Zener diode itself typically didn't have much current handling capability, and the Zener diode would then fail. The Zener diode would try to hold the power supply at the output voltage, and then eventually the Zener diode would fail, and when that failed, then the voltage went up again and blew everything up. At least Sony did it right. Put an SCR in that can handle more current than the power supply is capable of delivering, and shut it down and keep it shut down. So we're going to clean this up, and then I'm going to get some caps. We'll change out the caps in here that are bad, all these ones, and we'll take it from there. Oh, look at this, a little ball of solder fell off from somewhere on this. I wonder where that was. That obviously been sticking around there from the day that it was made. Leaking? Long life, yeah, right. 1000 at 16.
Geez, as I'm editing this, I can smell the smell from those caps. They just stink.
The 1000 at 16, you can see it's pissing on the board.
Just horrendous. These were, I think, the fish oil type caps. It just smells like the back end of a fish boat with a bunch of rotten fish in it.
Another 1000 at 16. Those ones for sure. Just want to clean this crap out of the board here. All this gunge on the board that's down in here. Well, I've still got my alcohol before it evaporates. That jumper's broken. You can see this. This jumper's been eaten right through. It's corroded right through there. This jumper here is probably also on the way out. But that one's broken for sure. Gotta make note of these caps. Write down what they are and where they go. .330. So I just kind of draw a quick little diagram. There's a 330, that one, the 470. There's nothing on this. There's an empty space there, so no cap. I'm just going to pull them all, and then I'll go and get some. This one here is definitely open. It's falling right apart. Yeah, that one, the pins actually fell right off. 330 at 16. that one. This one's a 10. And this one is another 470. So these are the ones I need to get. So I got two 330s, two 470s, three 1000s, a 47, and a 10. That's what I need to fix this one. At least to change just these parts out. So I'm going to make a trip down to the electronics store and I'll pick some up. And we'll get those replaced and see whether this thing will turn on. There's probably more wrong with it than that, but we got to start somewhere, right? This SCR might also be popped. I'm going to check it to see if it's shorted before I go. Make sure I don't have to get one of those as well. But anyway, that's the damage. That's the area of the board that's got the most damage is right in here. So off to RP Electronics. All right, I got some new capacitors. We'll start populating the board. I'm going to replace that jumper first. It's in the back there, make it easier to get at before the parts are put back in. But there's a jumper here that's completely. How's this diode? Is this eating away too? I hope not. Probably get a nice infection on my finger here from when I pulled out one of those pieces of jumper wire that broke and it slipped and stabbed me. This is a jumper wire that's going to get replaced from the top side here. And this one actually is what takes power over to this regulator IC over here. IC2. That controls the, I think that's the opto coupler. That's what controls the regulator anyway. Is that little IC. And this is what brings the reference voltage over. So with this jumper that was all corroded, there was no reference voltage. So we'll put this back through here. Pull this jumper down and solder it back down to the board. Problem when you work on this stuff with whenever you get this acid that leaks out of the caps and it gets all over your soldering iron when you're taking the dead parts out, it tends to attack the tip. So I have to really clean the iron well, otherwise you won't get good heat transfer. So these are the 1000 microfarad caps that are going in. So this will get the caps that were leaking replaced, and we'll do an inspection on the traces and make sure that none of the traces are open, and then I'll try powering the power supply up and see whether it fires up or whether we've still got a fault. We'll do it outside of the machine, obviously. But these were ugly designs, all of these machines. If you have one of these machines, these caps need to be changed. Whether it's still working or not, they do need to be changed. And if it hasn't leaked yet, it will. Because the failure rate on these was 100%. This was made during the capacitor plague era that affected all of these machines. Now I need to burn through a lot of the crap that's on the board itself, so I'm raising the temperature of the soldering iron quite a bit to over 800 degrees so that I can actually get the solder to flow and stick to components that have been affected by the corrosion. We'll reflow these ones and get these resistors and so forth to re-stick to the traces. This is absolutely the worst condition that you can find these boards in. And people wonder why I don't want to work on camcorders that have had leakage like this, because it's bad enough when you're dealing with a board that's got regular size components on it, but when you're dealing with surface mounted parts and the boards are damaged like this, and worse, this is a single layer board, so there's not really much that's going to go wrong with the board other than traces. When you've got a multi-layer board, this crap soaks into the board and attacks the traces, internal traces, and you're not fixing that. You got to change the board. And I get people sending me requests all the time wanting me to fix like CCD F50s and so forth, and TR5s and TR81s, and I tell them the same thing. You know, they're just not worth fixing. And I also warn people, you know, be careful, because somebody out there is going to attempt to do it, and they're going to charge you a lot of money for something, but you can't guarantee, when you've got a board that's damaged like this, you can't guarantee that it's going to fix it and it's going to last. I know there's a bridge here, I got to take that out. I just want to get the connections good first. Like even this is going to work now, but you know, there's always a possibility that one of these traces that's not open now will open up down the road. So it really makes it hard to guarantee that something like this is going to last. We do the best we can, but when you're in situations like this where there's such severe damage to the board, you just don't know. You know, when you get a trace like this, it's just all corroded. About the only way that I can guarantee that this trace isn't going to go bad is to actually put a jumper wire right over top of it, which is what I'm going to do on these ones that look really, really bad. I'm just going to replace it with another wire that goes right from there over to where it connects on the other side. That's about the only real way I can really have any chance of guaranteeing that that is not going to act up in the not too distant future. check the continuity. Make sure we have continuity. Okay. Yeah, I got continuity there. Okay, that's a ground there. Ground to those two pins. Okay, that goes to both of those pins. Yeah, pretty bad shape, these boards. I think it's okay. I think I've got all the connections redone and the capacitors replaced, so we can quickly power this thing up and see whether I've got any voltages or whether it goes into immediate shutdown. Move everything metal away from here that can short out. And I don't like I plugging this into the dim bulb really won't do anything, because something like this is it's a switching power supply. So as soon as the cap charges up, whether I give it a low voltage or not, it's going to start running. So let's make sure nothing's around here to short out and see if it starts up or whether it starts to squeak. Oh, good, it's not squeaking. I don't see any smoke. That's a good sign. Let's just see whether we get any voltages on here like we're supposed to. Okay. 3 volts. 39 volts. 18 volts. And we got power. 12 volts. 10. I think this thing's starting up, so I think at this point I can put it together and we'll put it into the machine and see if it powers up. Big question is the machine going to turn on? I heard it beep. That means that something's good. The vacuum fluorescent display is there, and it's got power. And it turns off, and it turns on. So, shall we try this and see if it plays? Alright, so this is the video coming off the tuner, and as you can see, it's compressed and distorted, and looks like they got the vertical blanking right there in the middle of the image because there are capacitors in the video circuit that have also failed. I want to see whether it'll play tapes first. We might do this as a multi-part video. I'm leaning that way now, as we'll do this as a multi-parter, because the power supply now is functional, but I want to see what other damage is done. We'll take a look and see if it plays. Obviously, it's not working properly for the picture. It looks like crap coming off the tuner. I'm just going to dig up a tape. We'll see if it plays. Let's see if it loads first. We'll see how many other problems this thing's got, because I have a sneaking suspicion that there's going to be more. And there certainly is, because the motors are not coming on to load the tape. So, we have more issues than meets the eye. The loading motor is not coming on at all. It's not trying to load the tape. So this, again, it's going to be a multi-part video for sure, because otherwise it would just go on far too long. So I'm going to end this one now. We know where we stand. We'll pick it up again in part 2, where I figure out why this transport's not working. And then we still got to solve the video problem, and it's going to have time-based corrector problems for sure, because all these machines do. They just loaded with caps that are going to be leaky, and I also got to get a hold of the guy and find out how far he wants to go on this thing, because it may turn out in the end that he wants to walk away from it, because don't know what's going to happen as far as repairing this one to completion goes. But we got to start somewhere. So power supply is working now. Now we got to deal with the rest of the problems. Also, remember when I was taking this apart that the screws were all loose. So somebody else has been into this unit. So I got to make sure that they haven't unplugged something and left it unplugged. Oh, look at this. Look at the board here. I just noticed this. Look at this. We have more corrosion on this one. Yikes. I wonder if this thing got water damage. Record Y. This is the record circuit. I wonder what else is wrong with this thing. You know, I've just put around $15 worth of parts in it just to get it to go, just to get it to this point. But this is definitely going to be a multi-parter. But I'm just going to pop this board open before we end this one and just see if there's anything obvious underneath here that's this is the audio AFM board. That's the, if I'm not mistaken, that's the time-based corrector on this one. I'm pretty sure that was the TBC board. But we have a problem with this mechanism anyway. It's not even attempting to load the tape. And that's plugged into the servo board over here. There's power to this because that chip is warm, so I know the board's got power. Yeah, time-based corrector. Okay, I'm just going to end this one right now. First, I got to talk to the guy that owns it and just find out how much money he wants to spend. This one was shipped in from a viewer. Actually, he brought it up here. He's from Portland, and he brought it up here and shipped it to me from Canada because his son came up when I was at work, so I couldn't meet him. But again, I gotta figure out how far he wants to go and probably look for some service data for this thing. As we can see on the picture here, it's got more than, it's got multiple problems because it's got a problem with the video as well. As you can see, sync problem, and we got video problems. We have servo problems. The motors aren't working. In addition to this mess that was the power supply that's now functional. And then there's this corrosion that I see on the board here. So I'm going to end this one now, and we'll pick this up in a future video, a part 2, and try to do it in 2 parts. Power supply is fixed. we'll deal with this. It might even end up being 3 parts, who knows. But first things first, the next thing we're going to have to deal with is getting the transport to load and unload the tape, because without it loading the tape, it's not going to play anything. Thanks for watching. We'll catch you in the next one. Bye.